Hello and welcome to another part of the random problem challenge. So today we're going to be doing another medium problem. And let's get started here. I'm going to pick a medium, a random problem. And once again, if we've done this problem, we are going to not do it. Okay, perfect. So let's read it. You're given an integer array nums. Some sequence of nums is called a square. Streak is a length. So let's write this down. So I do like to write it down because I feel like I remember things better if I write it down. So if that helps you, then feel free. Okay, so you are given an integer array nums, subsequence nums is called a square streak if the length of the subsequence is at least 2, and after sorting the subsequence, each element. Okay, so square streak, length of subsequence, let's see, after sorting subsequence, each element except the first element is a square of the previous number. Return the length of the longest square streak in nums, or return -1 if there is no streak. Okay, so this part is important right here because now that's one thing you want to look for these problems is if something is a continuous subsequence, then you can use something like a 2-pointer, and I think that would be pretty straightforward, right? So if it was only a continuous subsequence, it would be really straightforward. What you would do is you would just sort the numbers. So if you have these numbers, you would have something like 2, 3, 4, 6, 8, 16. And you can just have a left and a right, the standard 2-pointer. And then you can just check, like, let's say you have something like a 2, you just say, like, okay, is 3 2 squared? If it's not, then we have to move our left here. Is 4 3 squared? No, it's not. We have to move again, we have to move again, we have to move again, and we have to move again. And so our biggest here is 1. But now, with a subsequence, you can delete elements. So like, looking at it right now, I think the answer would be like this. Let's just say, so it'd be 2, 4, 8, like this. Is that right? Oh, sorry, without the 8. So it'd be something like that, because you can delete elements. And so as soon as they tell you can delete elements, I would encourage you to look immediately towards DP, because DP is very nice towards deleting elements. But you can't do something like a 2. Now, actually, let me think. Let me think here, actually. So this is, okay. I am starting to think of something else. Yeah, but the problem is that solution. So a DP would have to save every index. So like DP would be big O of n, best case of time. I am starting to think of something else, and the solution I'm starting to think of is instead of a DP, we can just... Yeah. So I think what we want to do... Yeah, I think I got it. But so what we're going to do, and I can write this down, is we are going to... Let's just write it here. Go through... Yeah, so we're going to go through nums and store every value in a set. Okay, so we just store every value in a set. Now, what we can do is then we can go through nums again, and if the... Let's think about how we would want to do this. Well, so this is kind of roughly, and then we can figure out exactly how to make it better. But if the square root of the number is in the set, then skip this number, actually. Skip this number. That's the best thing to do. Yeah. Here we go. Perfect. Okay, so our plan is this, and then if not, then we just go all the way up. Okay. And so our logic is going to be like this. So let's say we have this example, actually. So we would store all of these in a set, which would be big O of n. Fine. Now what we're going to do is, we're going to, for every number, we're going to check, is the square root of the number in the set? Because what we really want is the longest square streak, right? And so the longest square streak, like let's say if we have a number 4, if the square root of 4 is in our streak, then we would want it to start at 2, right? Like, if the square root of the number is in the streak, then the longest streak is going to contain the square root, or is going to start at the square root of the number, right? And so we would go through 4, we'd say, is 2 in the streak? Yeah, it is. Okay, move on. 3 is... And also, if the square root... so, by the way, another thing is, if the square root is not an integer, then we can just start at the number... no, it's fine. We can... Yeah, so it's fine. So, if the square root is not... So, the square root of 3 would be like 1 point whatever, right? And we would say, okay, well, 3, we'd start at 3, and we'd say, okay, our sequence starts at 3. Do we have a 9? No, no 9. Okay, go to the next number. Is the square root of 6 in here? Obviously not. Start at 6. Do we have a 36? No. We start at 16. Do we have a square root? Yes, we do. So we skip that. Now, we start at 8. Do we have a square root? No. So we start at 8. So we try 8. Then we try 64. And then we are done because 64 isn't in here. And then 2. We say, is the square root of 2 in there? No. Okay, so we start at 2. Okay, we have 4. That's in there. And then we have 16. And so that would be our solution. So in order to have this be big O of n, what you need to do is you need to save all this in a set. And then you need to go through it, and you need to make sure that when you do this streak, you start at the smallest possible number, and that would be big O of n, because it would ensure we only do something for each element one time, right? So, like let's say some streak is like 2, 4, 8, 64, and so on. We're not actually gonna be like, okay, let's start at 4 and do the streak. We're just gonna say if the square root is in there, then we just don't care, because our solution has to contain the square root. So hopefully that makes sense. Let's code it up. So first what we need is a set, right? So just like numbers set. I think it can literally take in nums, pretty sure. I just want to check this for syntax. Obviously, like this is like, I think you can do something like this, but let me just check. Yeah, and there's obviously a safe way to do it where you just loop through, but I think this works too. Okay, cool. So that works. Okay, so now we have to have a res, right? So like res equals 0, let's say. Let's just say res equals -1, actually, right? Yeah, we could start at -1, and then if we don't have, okay. So here we go. So for num in nums, we don't actually care about the index. So if square root, I think I can just do, I think it's like this. No, I don't want integer square root. I think I just want sqrt. What's the syntax for square root? Okay, I think we can just do this, but let's just see. We could technically do integer square, but we don't want to do. No, I think it's literally just square root. Okay, well, let's see if we get an error here. So square root of num is in numbers. Sorry, not in numbers, right? So if it's in numbers, we just move on. If it's not in numbers, now we do our stuff. I guess we could do it. We could do it like this, right? We could just have it continue here, there. So the square root is in the numbers continue. We don't care. Now, if the square root of the number isn't, then that number is going to be the start of some streak, and we don't know how long that is. But this is where we need to do the, the actual, like, count the streak situation. And so we can just say cur count maybe equals 0, right? And then we could say cur equals num. So then we just do a while. So we could do like cur, while cur in numbers, cur count plus equals 1, and cur equals cur times cur. Yeah, so like for a number like 2, we would say, okay, the square root is not in numbers. Let's continue. Okay, so our current count is 0. Our current number is 2. And then we say while 2 is in numbers, right? So we increment the count here. And then we say, okay, let's do the next number. And if that number is in numbers, then we do the next number and so on. And so at the end of this loop, we're going to have a cur count. And so now we just do if. So remember, the square streak has to be longer than 1, I think. So cur count is greater than 1. We could also add another continue to ensure that. Yeah, I guess sure, why not? So if square root in numbers or num times num. So yeah, so is not in numbers, right? So this will just ensure that we don't we only look for numbers that have a streak of 2. So like if we go to a number like 4, we say is 16 in it. Okay, fine, let's continue. And so for this whole thing to not continue, the square root has to not be in there, and the square has to be in the in numbers. Okay, so now we just do res equals max. We just try to get the max here, right? Cur count. Okay, and then we just return res here. I think that should be it. Let's just double check our code, because like I said, for an interview, you'd ideally want to double check your code instead of just running stuff. So numbers equal set looks good. Okay, res equals -1 looks good. For num and nums, if the square root of the number is in numbers, then we don't want to do anything. Or if num times num is not in numbers, you don't want to do anything. Okay, perfect. Cur count equals 0, cur equals num. Well, cur in numbers, cur count plus equals 1, cur equals cur times cur. Yeah, looks good to me. And then, yeah, okay. Cool. Nice. Okay, so this is pretty straightforward. There are probably like other ways to do this, but I don't know if there's a way to do it. So the nice thing about this solution, by the way, is we didn't sort, which is kind of nice. So our time complexity is as small as possible. I don't think you can have anything else. Also, this subsequence, if you did something like DP, we'd have way more states. So like we'd have a visited set. So you already know that like that would be way more space complexity. So I do think this is a pretty efficient solution. But let's just do the time and space here. So time, we are just looping through nums one time. And while we do have a for and a while loop, the thing to remember here is actually we are actually only checking each number once, because like we are going to check the sequence 2, 4, 16 here, but we're only going to check it starting at 2. For all the other numbers, we're just going to continue, right? So when we start at 4, we're not doing anything. When we start at 16, we're not doing anything. We're only going to do it here. So this is actually big O of n. We are going to loop through twice, but it's big O of n. So this is big O of n, and this is big O of n as well. Because, yeah, we aren't doing like this isn't really a nested loop. We're only starting at numbers that are the start of the subsequence, which means this while loop is never going to start, or this while loop is always going to include different numbers. So hopefully that makes sense too. And if not, you can ask in the comments and I'll clarify it some more. Okay, and space is going to be big O of n because we do have a set, right? Okay, so big O of n, big O of n. Now last thing, let's just look at the editorial. Oh, there's no editorial. I guess let's look at the solutions and see if that's roughly what people said. So let's take a look. Hash map and sorting. Okay, simple Java. Space. Okay, so that's just, I mean, we got the old clickbait. Let's take a look. Set. Yep. So this is pretty much what we did here. Yep. Okay. So I think, yeah, beat space, beats 100. Let's actually see how ours did, by the way. Let's take a look. So it beat 90. Yeah, I mean, it's super efficient. So I don't think there's, I mean, maybe there's something better, but I don't see how you could have anything better than O of n. And space, I don't think you can not save anything. Like, you might be able, yeah, so if you sort, then you can, no, actually, no. If you sort, sorting doesn't help, like I said, because it's not a continuous subsequence. So even if you sorted here and you'd have some stuff like this, it still wouldn't help you, right? If you had 2, 3, 4, 6, 8, 16, even if you sorted, you can't just be like, is the next number in here, because the next number can be anywhere, because we can delete a bunch of elements in the middle. So once you recognize, like I said, sorting doesn't help, then you can think of this solution, and this makes perfect sense. Okay, otherwise, if you couldn't do things like this, if you couldn't check right away, then usually for these non-contiguous subsequences, you have to do DP. And so recognize that for continuous, it's usually going to be a left and right pointer, 2-pointer, but then if it's non-continuous, then you need DP. Okay, so that's all for this question, and hopefully you liked it, and if you did, please like and subscribe, and I'll see you in the next video. Thanks for watching.